Welcome back, guys. This is your math exam coach. Today with a question that is going to tie in different aspects of what we've been learning. So we have an integration question which is going to tie in some substitution, and we have to understand how to do integration and differentiation for trig functions. Alright, so here's the question. So by using substitution u equals sine x, or otherwise find the exact value of the integral of cosine x divided by 3 plus cosine squared x. Alright, so before we jump into this question, please make sure you subscribe to this channel. Make sure you like this video if you find it useful, and share it with others as well. And if you want to try to solve this question on your own, you can just pause this video and you can solve it, and then you can restart it. Okay, so we're given u equals to sine x. So I'm just going to use that directly. I'm not going to use a different approach. So our value of u here is sine x. What we can do here, we know that du is going to be, so the first order differential of sine x is cosine x. So it's going to be cosine x dx. That's how we get du here. When we do that, we also need to change the limits. So we also need to change the limits, because here we're now using since we're using a substitution, we can't continue using the same limits, so we also need to take into account those limits. So when x equals to 0, so this is similar to just say sine of 0, and sine of 0 is 0, therefore u is equals to 0. The second one is when x equals to pi over 2, that's the upper limit. So this is the same as sine pi over 2. The sine of pi over 2, which is 90 degrees, is the same as 1. Therefore, u equals to 1. So these are our new limits. Okay, so since we have those new limits, we can now use this the sine x and rewrite this function again. Right, so let's do this. So I want to rewrite the cosine x over 3 plus cosine squared x. So this is going to be the integral. So now we know that, so right now it's still over pi over 2. So this is cosine x over 3 plus, what do we know? So we know that du equals cosine x dx. So the numerator here is already solved for. But cosine squared, we can express this as 1 minus sine squared x. So that means we can rewrite this as pi over 2, 0 cosine x dx over 4 minus sine squared x. Right, so cosine x dx is similar to du. 4 minus sine squared x, we can substitute u as sine x. So we can rewrite this as our upper limit is 1, our lower limit is 0, which is cosine x dx over 4 minus u squared, since sine x is equals to u. Therefore, we can rewrite this as 1, 0. Cosine x dx is the same as du over 4 minus u squared, which we can also rewrite as du over 4 minus u squared. We can simplify that to 2 minus u, 2 plus u. Right. So let's continue here. What we have is an integral of 1, 0 du over 2 plus u, 2 minus u. And so what can we do about this? So we can express this. This is similar to 1, 0, 1 over 2 plus u, 2 minus u du. So we can, this is a little bit difficult to integrate, so we can use partial fractions. Partial fractions decomposition. So 1 over 2 plus u, 2 minus u, we want to find an equivalent of that in terms of a over 2 minus u plus b over 2 plus u. Right, so this is this can be simplified as we have a 2 plus u plus b 2 minus u over 2 minus u 2 plus u. So we have seen in other tutorials in the past where we solved for this. So you can refer to that tutorial to solve for this. But when you do, we're going to find a to be equals to 1 over 4 and b equals to 1 over 4 as well. So that means we can rewrite this integral as 1 over 4, our limits are still 1 and 0, du over 2 minus u plus 1 over 4 integral 1, 0 du over 2 plus u. Right, so what we have here is still a little bit challenging. 1 over 4, 1, 0 du over 2 minus u plus 1 over 4 integral du 2 plus u. So we can substitute and say let z equals to 2 minus u. So, and let y be equals to 2 plus u. So we can rewrite this as 1 over 4, 1, 0 du over z plus 1 over 4 du over y. But we know that dz du is equals to, for the first one it's -1, therefore du is equals to negative dz. And we can do the same here. So for the second one, du equals to dy. So we can rewrite this as 1 over 4. So this becomes negative because we have that. So this is dz over z plus 1 over 4 dy over y. So we know how to solve for that. So this becomes negative 1 over 4. The integral of dz over z is same way 1 over x. So this is ln z plus 1 over 4 ln y. But we know what y and z are. So we know this is z, this is y. So that means our integral here is negative 1 over 4 ln z equals to 2 minus u plus 1 over 4 ln 2 plus u with these limits 1 and 0. Right, so we can substitute those limits now into our equation. So we have negative 1 over 4. So what we have is negative 1 over 4 ln 2 minus u plus 1 over 4 ln 2 plus u with the limits 1 and 0. Alright, so let's simplify this quickly. What do we have here? So this is similar to, now we can use the laws of logarithms. We can rewrite this as 1 over 4 ln 2 plus u minus 1 over 4 ln 2 minus u, which is similar to 1 over 4 ln, since this is a negative, same as 2 plus u over 2 minus u. We still have the limits 1 and 0. So what do we have here? So we have 1 over 4 ln, which is 1. So this is 2 plus 1, 3, 2 minus 1, which is 1, minus ln 0, so 2 over 2, which is 1. This, so we know that ln 1, we are going to make this to be, we can rewrite this actually as 1 over 4. Again, using laws of logarithms, this is 3 over 1. Therefore, our answer is 1 over 4 ln 3. So that's our solution right there. Awesome. So if you like this tutorial, make sure you like, make sure you subscribe, make sure you share with others. Until next time, goodbye for now.